Hey folks, today's topic is summation notation and factorials. So summation notation, so I talked last time a little bit about sequences. Well, I talked a lot about sequences. Sequences were a list of numbers, but I also mentioned these things called series. And series are that same list of numbers. It's a sequence, but instead of just writing down the list of numbers, we take those numbers and add them all together, and that creates this thing called a series. So let's define that. Definition. A series, underline the word series. A series is the sum of the terms of a sequence. Now, we write a series using this stuff called summation notation. Now, you might have seen it before. We use this symbol. This is the Greek letter sigma, and it means add up or sum. We add from all the numbers from k equals 1 until n of a sub k. So what this notation means is we take this k equals 1 and we plug it in. Now this is going to be some formula. I look down here, 4k plus 1, there's my formula. So what we do is we take this value, we plug it in, we get a number, we get a term. We call that the first term would be a sub 1. Now, if this was just making a sequence, we'd write comma and the comma in the a sub 2, comma a sub 3. But because it's a series, we would add then. Now I would plug in, after I plug in 1, I would plug in 2, a sub 2, and then add. After 2, I would plug in 3, and then 4, and then 5, and then 6. And then we'd go all the way until we plugged in whatever this number is, a sub n. So that's this. This is called summation notation. This is kind of explaining how summation notation works. And then this is a series, this idea of adding together those values. So let's do an example where we actually compute the sum. So I've got this series that's given in this summation notation. So I'm going to first plug in 1 into this. So my first term would be 4 times 1 plus 1 plus, now I'm going to put in my second term, 4 times 2 plus 1 plus 4 times 3 plus 1 plus 4 times 4 plus 1. Now, why did I stop there? Why is this my last? Because I plug in all the numbers from this first value for k until I get to the top. So I plugged in 1, then I plugged in 2, then I plugged in 3, then I plugged in 4. Now I would calculate this. If you can do this in your head, great. I'm not gonna. So what would this be? This is 4 times 1 plus 1 plus 4 times 2 plus 1 plus 4 times 3 plus 1 plus 4 times 4 plus 1, and we get a total of 44. So this series adds up to 44. Now that you got the idea, let's have you try the next two. I think I'm just going to do it on the calculator. So what would I calculate first? I would have 3 times 1 plus 2 plus 3 times 2 plus 2 plus 3 times 3 plus 2 plus 3 times 4 plus 2 plus 3 times 5 plus 2. Should have got 55. Pause, try the next one. Be careful though, it's a little bit sneaky. Be ready for it. All right, I'm not sure if you noticed, but this K value starts at 3. So I would only plug in 3, 4, 5, and then 6. You don't always start at 1. It's whatever the K value starts at the bottom of our sigma. So that would be 1 plus 3 squared plus 1 plus 4 squared plus 1 plus 5 squared plus 1 plus 6 squared. We should get 90. All right, so hopefully that helps a little bit or reminds you of how summation notation works and what a series is. The second part of today's notes is talking about these things called factorials. So 8 factorial, let's review first what it even means, what factorial notation or what this symbol factorial does to this number. Factorial means you take this value and you multiply 8 times all the numbers less than it. 7 times 6 times 5 times 4 times 3 times 2 times 1, and we don't times by 0, because if you times by 0, every factorial would always be 0. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 ends up being 40,320. Luckily, there's a shortcut way to do this on our calc. You want to put the 8 in there first. I'm going to bring up what I had last time. I want to put the 8 in there first, then I go to everything good for graphing is underneath calc. Everything good on this screen is underneath math. Then we're going to go over to PRB, which stands for probability, and then you'll see the exclamation point, enter. So 8 factorial, and it gives us this answer. So it's the same thing. If you want to type it out, go for it, or you can use the factorial. All right, now, the reason I'm picking, so the next couple ones, we're going to figure out how to do factorials with really big numbers. Like if you try to do 75 factorial, your calculator says that number is so huge, I cannot compute it. So how would we clean up something that has a 75 factorial in it? Well, we'd use this sort of trick that factorials contain other factorials. What I mean by that, well, first of all, let me explain. I know you could do this on your calc. I don't recommend just doing it on your calc because you're missing out. You're missing the big picture on how we're going to use this trick to help us when we've got such big numbers. So let's look at what does 8 factorial really mean. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over. Now we're going to write everything out this time, and then I'm going to show you a shortcut so you don't have to write every single piece out. 2 factorial means 2 times 1 times 6 factorial, 6 times 5 times 4 times 3 times 2 times 1. Notice what happens here. Do you see some stuff cancel? Yeah, you should. Look at 6 factorial, 6, 5, 4, 3, 2, and 1 all reduce. All cancel out, and we're left with just 8 times 7 over 2 times 1. So this is much easier to compute. But what I want to do is I want to rewrite this thing in a way that I don't have to write it out every single time. And the point that I'm trying to show you here is that 8 factorial, after you do 8 times 7, what you have is 6, 5, 4, 3, 2, 1. You have 6 factorial. So I really want to rewrite this thing as 8 times 7 times, instead of 6, 5, 4, 3, 2, 1, I'm just going to write that as 6 factorial over 2 times 1 times, and then this time I'm not going to clean up or expand that factorial, because I want to leave a 6 factorial on the top and a 6 factorial on the bottom. Those 6 factorials are going to cancel out. Let's see, what else can we do? We can kill out the 4 and the 8 and the 2. That would leave 4. And then 4 times 7 equals 28 over 1. 28 over 1 is just 28. So we took something that was pretty messy with some factorials, and we canceled out the factorial part and made it something much more manageable. Let's try another one. So let's try 2 factorial, 10 factorial, 8 factorial, and 5 factorial. My advice is you want to look at the biggest factorial on the top and compare it to the biggest factorial on the bottom. So on the top, I've got a 10 factorial. On the bottom, I got an 8 factorial. So the 10 factorial contains the 8 factorial. So I'm going to break up 10 factorial as 10 times 9 times 8 factorial times 2 factorial over, now I've got the 8 factorial. I want to leave that as an 8 factorial, so those two things will cancel out. Now I'm going to manage the 5 factorial, but the 5 factorial contains the 2 factorial. So I'm going to break down the 5 factorial until I get to 2 factorial, and then I'm going to stop. 5 times 4 times 3 times 2 factorial. And now I've got some stuff that cancels. So I can kill off 8 factorial with 8 factorial, 2 factorial with 2 factorial, and then from there you can either grab your calc to compute this, or you can start to cancel more. I think I'm going to go to my calc this time. So 10 times 9 divided by 5 times 4 times 3. So 90 divided by 60. Then I'm going to frac it back, and I would get an answer, nice cleaned up answer of 3 over 2. All right, let's have you try the next one. I'm going to encourage you here to pause and try to do the next one on your own. All right, let's see how you did. So I want to do 75 factorial, 11 factorial, 15, and 73. I start with the biggest on the top and the biggest on the bottom. Compare them first. So who contains who? So the 75 contains the 73. So I'm going to start to break down the 75. 74. Then I'm going to stop at 73. Because in the denominator, I've got a 73 factorial that I can work with. Now, the 15 is bigger than the 11, so I'm going to leave the 11 factorial on the top. And I'm going to break down 15, 14, 13, 12, and then 11 factorial. That's a 14, believe it or not, but that's what it is. So now let's see what can we kill off here. 73 factorial, 11 factorial. You could still cancel like 75 and 15. I know those reduce, but I'm going to go to my calc at this spot. I'm going to do it with the frac or the fancy fraction button. 75 times 74 over 15 times 14 times 13 times 12. Frac backs to be 185 over 10, or 185 over 1092. So what, as always, I like to say this a lot, if you can do mathematics in both directions, you really understand it. So in this case, I gave you the factorials, you broke them down and cleaned it up. This is after I've already canceled out the factorials that cancel. What would you have to have set up so that you would get this as your leftover pieces? In other words, I'm giving you what's still living after you cancel the factorials. Well, look at it this way. If I have 10, 9, 8, and it stops there, what would be the rest of this? It would have to have a factorial of 7 after it. So when I clean this up, I'm going to have 10 factorial on the top, but I want it to stop at 8, which means I need what on the bottom? I need a 7 factorial on the bottom. Because when I go 10, 9, 8, 7 factorial, that's going to cancel with whatever that 7 factorial is. Same thing with this 6. I want a 6 factorial on the bottom, so it goes 6 and then 5. But then I want everything from 4 on down to cancel out. So I need a 4 factorial to cancel that out. If you're not sure, go back and expand it like we did here. And you'll see that what will be left over before we compute it will be 10, 9, 8 over 6 times 5. Okay, the last section is dealing with what happens when we don't know the actual number that we're starting our factorial, but we know that it's a factorial. So, like when we did 75 factorial, how did you know 74 was going to be the next term that you wrote down? 15, then 14. How did you know it was 14, then 13, and 13, then 12? What did you do to these numbers? Well, we subtracted 1. So if we have n as our first factorial, 75 factorial started at 75. So n factorial is going to start at n times, and then who's the term right before n? Well, who's the term before 75? 74. How did you get that? By subtracting. So I'm going to subtract 1. Who's the term before n minus 1? N minus 2. Who's the term before n minus 2? N minus 3. And so on and so on and so on. Over, let's do the same thing on the bottom. N minus 1 factorial. That's going to start at n minus 1. Who's the term before that? N minus 2. Before that, n minus 3. Before that, and then so on from there. So you'll notice that we didn't probably recognize this right away, but there are a bunch of terms that are going to cancel out. N minus 1, n minus 1, n minus 2, n minus 2, n minus 3, n minus 3. What would be the next term here? N minus 4. How about here? N minus 4, n minus 5, n minus 5, n minus. Those are going to cancel out as well, and we're left with, in this case, just an n in the numerator, n over 1 would just be n. Okay, so let's try that again, but let's try it with a, for this one. You try it on your own. Let's see how you do. Hopefully you paused and gave it a whirl. So n plus 2 factorial starts with n plus 2. Then it goes to, shouldn't say, the next one, who's 1 less than n plus 2, would be n plus 1. Then n minus 1, then n minus 2, and then so forth. You might say, how do you know how far to go? You kind of look at the denominator to give you a hint. So I knew I had to go to at least I got an n so that stuff would start to cancel out. Now in the denominator, I'm going to start with an n times an n minus 1 times an n minus 2 times a dot, dot, dot. And so you can start to see that things are going to cancel here. The n's are going to go, the n minus 1 is going to go, the n minus 2 is going to go, and then the dot, dot, dot is going to go. Now, because these two things can be combined, I expect you to actually multiply them out. Like up here, we actually did 75 times 74 and 15 times 14 times 13 and 12, and then reduce that fraction. So here I expect you to distribute these two quantities. N times n would be n squared. That would be 1n. That would be 2n. So that's 3n. And then 2 times 1 is 2. Alrighty, folks. There you go. You got a little factorials and then some summation stuff to check. Homework's on the back. Go get them.